Welcome back to Spring Into Math 8. I'm Mr. Burns. Today's topic is identifying a terminating or terminal decimal as well as identifying a repeating decimal. Let's go ahead and jump right in. So, first things first, we need to discuss an overall definition of really what is a terminating decimal. So here we go. Some fractions are equivalent to terminating decimals. We should know that fractions, when converted to a decimal form, can convert into what we call a terminating decimal. But here's the real finite definition. A terminating decimal is a decimal that has a finite number of digits. And that word finite kind of needs a sub-definition here. So finite means it has a specific amount. And that amount can vary from 1 to 10, or even more than 10. So let's go ahead and take a further look. Here are some examples of terminating decimals. First, we have 0.5. Now, 0.5 is equivalent to the fraction 1/2. And we divide 1 by 2, we get 0.5. And that is it for the decimal. So therefore, that is a terminating decimal. We also have 0.75 here, and that is a fraction equivalent of 3/4. And when we divide 3 by 4, we get 0.75, and that is it. So therefore, we also can call that a terminating decimal. Our last example here is 0.23958. Now, I'm not really sure what the fraction equivalent to that decimal is. However, we can see that it does end at that digit of 5, and so therefore, we can call that a terminating decimal as well. Let's talk about what a repeating decimal is. So a repeating decimal is a decimal that has specific digits that repeat over and over forever. When I mean forever, they mean you can get out 10 pieces of school paper and you could write that decimal out forever and ever and ever, and when you got to the bottom of that 10th page, you'd still have to write that decimal because it repeats forever. You could indicate that these digits repeat by putting a line over the top of the digits that repeat. Let's take a quick look at some examples of repeating decimals. Here are some examples. We have 0.3333, or we could write out this in a smaller format by putting 0.3 with that line over the top of our number. We also have the decimal 0.123, 123, 123. Now we need to look for where this decimal repeats. We have 1, 2, 3, and then that 1 repeats itself again. So that's where we can stop and we shorten our decimal. And again, we can put that line over the top to show that those are the repeating digits in this repeating decimal. Let's try an example. So we need to convert the fraction 5/6 to a decimal. So first, we need to divide 5 by 6. So we're going to use our long division skills we learned a long time ago, and we're going to check out and look for a repeating pattern where we divide these two numbers. 5 divided by 6 is the decimal 0.83333. Do you notice the pattern? Which number is repeating in our decimal? In this case, it's a 3. So we can write this in a shorter form by doing the following. Put our decimal, 8 and a 3, and put that line over our 3 to show that that is the repeating decimal. Here we go. I want you to try these on your own. So go ahead and pause the video if you'd like and give these a try. So we're going to convert 4/9 to a decimal as well as 12/6 to a decimal. Now after you convert them, you need to decide, is it a repeating decimal or is it a terminating decimal? I hope that you were able to get the first one right. 4/9 is equal to 0.444. And that's a repeating decimal because that 4 continues to go on forever and ever. Last, 12/16 has converted to the decimal 0.75, which we can consider a terminating decimal because it has a specific end. It ends after that 5 and goes no further. Well, that's it for today, guys. I hope you enjoyed the lesson and good luck solving.